Hi friends, welcome back. Today we are going to solve another very important and popular Facebook, Google, Microsoft coding interview question. It's on Leetcode 236, lowest common ancestor of a binary tree. So as you can see here, this is another quite likable and very important coding interview problem of medium complexity. So this is a binary tree coding problem which got asked many times in the interview. So we are going to solve this problem today. We are also going to implement our Java solution code. So let's start. Given a binary tree, find the lowest common ancestor LCA of two given nodes in the tree. According to definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of itself. Okay, so that's the definition of LCA. So let's take a look at the constraint. Says that the number of nodes in the tree is in the range of 2 to 1 lakh. 10 raised to 5 is 1 lakh. Nodes will be their maximum. The node values will range between minus 10 raised to 9 to plus 10 raised to 9 inclusive. All the node values are unique. P is not equal to Q. P and Q will exist in the tree. So these are given to us. So let's take a look at some examples so it will be more clear. So this is a binary tree that is given to us here, right? So P value is 5 and Q value is 1. So 5 is here, you can see here, right? 5 and 1 is here. So the lowest common ancestor for these two nodes is 3. You can just visually see here it is the lowest common ancestor, right? 3. So that's what the answer is. Here is another example. Here P is 5 and Q is 4. So 5 is here, right? You can see here 5 and 4 is here, right? So the lowest common ancestor for both the nodes is 5, right? As you can see, 5 is the lowest common ancestors. So that's why you have to output 5. So according to their definition of LCA, right? So here is another example I created here to discuss more for this problem. So there are two nodes given here, right? 11 and 350. So we want to find out LCA for 11 and 350. So as you can just visually see, the LCA is 100, right? For 11 and 350. Why? Because that is the lowest common node, ancestor node, right? Ancestor node. Okay. Okay. So if they ask you that lowest common ancestor between 11 and 80, then which one will be lowest common ancestor? 50, right? Because 50 is common node, ancestor node, right, which is lowest level. Okay, so this is what the problem says. So I hope the problem is clear to you. So now we will understand the logic how we can solve this coding problem. So what we can do to solve this coding problem is we can create a child parent map from this given tree. We can create a map basically using a BFS like approach. We can create a map, right, of child and parent. So you can start a BFS from this node, which is a root node, and you will start populating a map. So what the map will so let's say, so we will just say that it's a child parent map, right? So I'll just write down here so it will be clear for you. So we'll create a map basically, right, of nodes. So these are unique values. Okay, so so let's draw a map here so it will be more clear for you. So this is the key is the child here, okay, and the value is the parent. So child value is 50, right? The parent for 50 is 100, right? You can see in the in this tree, right? The child is 200, parent is 100. Then child is 10, parent is 50, and child is 80, parent is 50. Okay, 50. Then child is 11, parent is 10, correct, and 300 and 10, and then 10, 310, okay, correct, and then 350 and 200. So this is the map that we will prepare first, right, from the given tree. So you can just do a BFS and create this map. So it's pretty easy. Okay, so now once we have this child parent map, then we know two nodes, right? The P node is 11 and Q node is 350. So let's call this P node. let's say, and this is a q node. Two nodes are given to us, as you can see the method signature here, right? So two nodes are given, right, p and q. So let's say p is 11 and q is 350. Now what we will do is we'll take this node p, which is 11 here in this map, right? And then we will we'll create one set, right? For node p we will create a set for node p, and this set will contain all the nodes which are node 11 and its ancestors. 11 and its ancestors. So 11, then the next ancestor can be 10, right? 10's ancestor is 50. 50's ancestor is 100, correct? So we'll create a set from this, right? How we can create a set? From this map, right? So you can start from 11. So 11's parent is 10, right? Then you go to 10. 10's parent is 50, right? 50. Then 50's parent is 100. And 100 parents is not there, right? Because 100 is a root node. It does not have a parent, right? So we'll stop there. So these are all the ancestors of node P. Similarly, we will also, now we will start looking into node Q, right? So node Q is 350. So 350's parent is 200, right? And we'll start checking if this value exists in this set, right? This value exists in this set. So 350 is not there, 200 is not there, 200's parent is 100, right? So 100 value exists. Yes, 100 value exists into this set. It means that it is a lowest common ancestor of both the nodes, right? So this is the basic logic to solve this coding problem. So I hope you understood this clearly now with this example. So I shown you child parent map and we have seen this logic, right? So you will after a child parent map we will create this set for node p that is going to give you the p node and its ancestors, and then we will start going taking the node q and start going through its ancestor, right? 350, 200, and then you will go to 100, and then you will find that 100 already exists in this ancestors list set, right? So it means that it is a lowest common ancestor of the binary tree for nodes 11 and 350. Okay, so let's go ahead code this Java solution now, so you understood this logic clearly. So lowest common ancestor is the method we're implementing. Root of a binary tree is given to us. Two nodes are given to us. One is P and other is Q, correct? And this one returns a tree node, which is the lowest common ancestor node for P and Q, right? Okay. We'll create a map. Map is going to hold tree node comma tree node because it is a map of child and parent, right? Child and parent. So set is going to hold integers, right? So hash set. Now this is a BFS that we'll be doing to populate this map, right? Because we have to create now populate that map of child and parent relationships. So now here we will create a queue that will hold tree node objects. This is essentially a linked list in Java, and we will start adding the root node into the queue, correct? This is the starting point for the BFS, and we will start adding the root and null as the key, because root is the child and it does not have a parent, so null is the parent basically, correct, for root node. Okay, so this is where our BFS starts. So let's put a comment here so it will be clear for you. So this is a BFS starts now. So now we are going to do BFS and populate our child parent map. While queue is not empty, we will first read the size of the queue. This size is important so that we know how many nodes to process for that BFS level, right? BFS is level order traversal basically. So it goes level by level. So we are reading how many nodes to process for that level in this size. In this for loop, we'll start processing those many nodes from the queue, correct? I is equal to 0, I is less than size I plus plus. So we'll start removing those nodes from the queue, and then we will check if that node has a left child, then we will add the left child into the queue. We will also add the child parent relationship in map. This is very important. This is where the map is getting filled, right? Temp dot left, so you are adding the left child and its parent is temp, right? Similarly for the right child, you will add the right child and its parent is temp, right? If the right child exists, you will add it into the map. you will also add the right child into the queue so that it can be processed further in further DFS iterations. Correct? Okay. So after this while loop is done, you have this map ready. So this is how your map will look like basically, right? But obviously these are tree node objects you will see in the map. Okay. So you have the map now. So now we will go through the node P and its ancestors. So while P is not null, we'll start adding the value of P into the set. We will start getting the parent of the P node, right? P is equal to map.get P. So you will next time add its parent, its parent, its parent like this, right? So 11, then 10, then 50, then 8, and then 100. So you will add these things into a set. So I shown you the set here. So this set you will get, right? Okay. So now after this one is done, now you also know the q node, right? So while q is not null, you will check if the set contains the q dot value, right? Then you will directly return q. It means that you found the lowest common ancestor. Okay, it means that you found lowest common ancestor. Otherwise q is equal to map.get q. So you will start going up basically, right? 350, then you will go to 200, then you will go to 100, and then you will find 100 into the map here, right? And then this is the lowest common ancestor. Correct? If you reach here, it means that there is no lowest common ancestor. You will return null. Okay, so this is the solution that we have, logic that we have discussed. So we just implemented it in Java. So let's test this out with some examples, make sure it gives us correct answers. So for the first test case, we should be getting 3, and we are getting 3, which is a correct answer. For the second test case, we should be getting 5, as you can see here. 5 is what we are getting correct answer. For the third test case, we should be getting 1. So this is the third test case, and we are getting another correct answer. Submit this code to the Leetcode, make sure it gets accepted. And as you can see, the code is successfully accepted by the Leetcode. These numbers are changing, so we'll try to resubmit this code so that we can make sure this gives us correct numbers. So this is how you can solve this very important Facebook, Google, Microsoft coding interview question on Leetcode 236, lowest common ancestor of a binary tree. Another very popular coding problem, as so these numbers are uh, changing, so I'm not sure about these numbers, but this is the approach you can use to solve this coding problem. So I hope you clearly understood this logic that we have discussed here, and how we have used this concept of child parent map to find out the lowest common ancestor of a binary tree. So I'm going to add this Java code in my GitHub repository and give you the link of this Java solution code so you can check it out. There are lots of other important algorithms and Java solutions which are already implemented and available there for you. Don't forget to check them out. They are quite important ones from interview perspective. If you like the Java solutions in the GitHub repository, consider giving it a star on the GitHub repository. That would be great. If you are new to this channel, we have created a very important coding interview related playlist to help your interview rounds. It is called as Leetcode and Leetcode Solutions. We have compiled more than 200 most frequently asked very important coding interview problems for you under one playlist. Those problems got asked by many big tech companies including Google, Facebook, Amazon, Apple, Microsoft, Yahoo many times in their interviews. Very important problems. Make sure you go through them, understand them well. If you go through those videos, you are going to learn a lot about data structures, algorithms, problem solving, logic building, Java programming and coding. It will also help you learn lots of new techniques, lots of new ways of different varieties of computer science related problem solving. You are also going to learn a lot of Java programming and coding on this channel. So make sure you check out those solved coding problems. The name of that very important playlist here is Leetcode and Leetcode Solutions. Now, if you are a fresher, junior level developer and you want to practice more coding problems, to help your practicing purpose, we have created 3 other playlists on this channel for you. The names of those playlists are Code Forces, CodeChef, at Coder. Code Forces, CodeChef, at Coder. All in all, more than 800 different varieties of problems are here to help your interview preparation and learning process. If you like this Java solution where we have used this concept of child parent map to find out the lowest common ancestor, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Subscription is very important because that's how the videos can reach to other people, so others will also be able to watch and learn from these videos. Do subscribe to this channel, click on the bell notification icon button right away so you won't miss any important postings from this channel. We often create and post videos here to help others learn different computer science concepts and learn how to solve different data structures and algorithmic problems. On this channel, you will find lots of solved problems that you can use to prepare well for your interview rounds. Those problems includes graphs, matrices, binary search trees, binary trees, breadth first search, depth first search, cadence algorithm, binary search algorithm, Kruskal's algorithm, Dijkstra algorithm, sliding window algorithm. There are also lots of important data structure questions available here, including stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, arrays, linked list. All those problems are solved and explained with Java code step by step so that you can clearly understand those logic as well as clearly understand those problems as well. So make sure you check out those important solved problems. They will give you a really good preparation for your interview rounds. Apart from lots of solved coding problems, there are other helpful videos also available to help freshers and junior level developers here. For example, frequently asked Java telephonic interview questions and how to answer them, Java design patterns, Java architecture, SQL programming questions to the freshers, where they will give you database tables. They will ask you to write SQL queries, where you may have to use different database concepts like inner join, outer join, left outer join, right outer join, aggregate operations, group by and having clauses, different where clause conditions. Everything is explained in those videos with examples. So you can also write those kind of SQL queries and solve those kind of SQL programming interview problems. Make sure you check them out. There are also videos that discusses recently asked Unix questions to the freshers. For example, Unix commands, Unix utilities, shell scripting questions, all are here to help your interview preparation and learning process. So if you like the videos on this channel, if they are helping your learning process, you are learning new techniques, more problem solving along with data structures, algorithms, Java programming and coding, then please leave your messages, your comments, your feedback below these videos. Your messages, your feedback, your comments all are greatly appreciated, very important and valuable for us. It increases our motivation to create more quality content. So if these videos are useful and helpful for you, then do leave your messages below these videos. If you have any particular questions also, you can leave them below these videos comments box. Also share these videos with all your friends so other people will also know about this channel. They can also watch and learn these videos. Keep learning, keep coding, keep solving more varieties of coding problems. And most importantly, keep your learning process going on continuously. And thanks for watching these videos.